So, as Brian said, I'm going to talk to you a little bit about how I used ants to help me understand the nature of science. So, I'm an undergraduate student at the University of Florida, and I'm set to graduate spring 2021. So, that's this coming spring. And as Brian said, I'm studying entomology and nematology, which is the study of insects for the most part. And I'm from Lake Worth, Florida, which is down in South Florida in Palm Beach County, where I graduated from Santa Lucia's High School in 2017. And I've kind of always had a broad interest in the natural world. I've kind of always had a broad interest in the natural world, and that's everything from plants to animals to what's in the sea, what's in the land. But ever since coming to UF and having a special and starting this specialized education in entomology, I think I've become particularly interested in arthropods. So that's all of what you think of when you think of like a bug. So that's your insects and your spiders and your scorpions and millipedes, centipedes, and crustaceans. All of those things are arthropods. And I've become interested in using those to explore questions surrounding conservation and ecology. And so far at UF, I've done work with ants, butterflies, moths, birds, and I'm currently working with frogs actually, but I'm doing a remote internship with them. So, one second. I'm having a problem, sorry. There we go. So as Brian said, I'm working in the Lucky Lab, which is a lab in the Department of Entomology, and for the past year and a half or so, I've been working as an undergraduate researcher / assistant / volunteer. And in the Lucky Lab, we focus on questions surrounding mostly ants. We branch off a little bit from that, but for the most part, we focus on ants, and particularly we study invasive ants. Now, invasive ants are really important to Florida because we have a whole bunch of them. So they affect our ecology, our economy, and our agriculture relatively significantly. So that's why it's important that we study them. And I actually just finished up an undergraduate honors thesis looking at the social structure of the little fire ant within the state of Florida. And this is one of those invasive ants that we have here. If you look over in the bottom right corner, you can see the little fire ant on a tip of a pencil. So they're really, really tiny ants, but they're really significant agricultural pests. So how did I actually go about doing this undergraduate thesis? So it started with an observation in 2018. In the summer of 2018, the lab found a permanent population of the little fire ant on campus at the University of Florida. Now, up until this point of time, we didn't think that the ant was able to establish this far north in Florida because we thought they would just die with the freezes each winter. But clearly that wasn't the case once we found this permanent population. So once we had this observation, we were able to actually start asking questions about them because we had such easy access to them on campus. And it's difficult to actually start asking questions if you don't have a basis to ask questions. So if you don't even know something exists, how are you going to ask questions about it? So once we started asking questions, my advisor came to me and she kind of started guiding me and she helped me come to a question that was actually answerable within the time frame that I had available. So things that make questions answerable for students can be something like, do you have the time? Do you have the resources, the money, the technology? Do you have the knowledge capable of answering this? There's a whole bunch of different things that go into making a question answerable or not, but those are just some of the things. So my advisor was particularly helpful in guiding me towards coming up with a question that I was able to do in the time frame that I had available to me. And then after you come up with a question, you can start formulating hypotheses for those questions that you have. And I think it's important that hypotheses don't necessarily always follow this rigid like if-then structure that we're often taught, but I do think that's helpful to introduce students to the idea of a hypothesis. And hypotheses are important because they show that the person who's asking the question is able to like reasonably predict why something might happen, what exactly might happen, and why, if something happens, why that might be important. Like what is that contributing to the body of knowledge as a whole? And these things are coming from like knowledge that already exists. You don't just pull a hypothesis from thin air. It's based on knowledge that we all have that's coming from somewhere. Now, after this, you're going to get results somehow. And these results are going to be based on evidence. And typically this evidence comes in the form of data. You can't just come up with a result with nothing to support it. And that looks like data, and data exists through data collection. And I think it's important to understand that not all scientific questions require experimentation. But of the questions that do require experimentation, you often need creativity and adaptability to actually figure out how to answer those questions and how you're going to do it. So I think any scientist in here, any scientist that you've talked to will tell you that it's not uncommon for things to go wrong or just flat out not work. In fact, it probably happens more often than not for something to go wrong. So in those situations, it's really, really important for you to be able to be adaptable to figuring a workaround to like, how are you going to get around that? What's the solution that you're going to come up with to make sure that you can still get the data that you need to answer the question that you're asking? Now, creativity is also needed in both experimental design and the interpretation of the results that you're getting from that experiment. So for example, going back to my ants, what we were doing is we were looking, like I said, we were looking at the social structure. So this required behavioral experimentations. What we did is we took workers from 2 different colonies of ants, and then we placed them into an arena together to see how they interacted with one another. But we wanted to make sure that we were able to tell the 2 different colonies of ants apart. And there's plenty of experiments, or plenty of protocols that already exist that for similar questions like this. So we were lucky enough that we didn't have to work from scratch in figuring out what we wanted to do or how we wanted to do it. Rather, we just needed creativity in modifying the protocols that already existed, but adapting them to answer the questions that we were asking in the way that we were asking them. So what we ended up doing is, before one of the colonies of ants were placed into the arena, we first put a dot of paint on them so we were able to identify them. And that's what you're seeing here. That's a little dot of paint on the head of that ant. And then after that, these are some of the possible outcomes that came from those trials that I did. And I don't think it's necessarily important to understand what these outcomes mean in this situation. I think I'm just showcasing here that it can be a little more complicated. Like I'm showcasing that it can be complicated to, when you get those results, like, what am I actually going to put down on the data sheet so that it can mean something in the future? And then, but this is also something that needs to be able to be objectively done by both you and future researchers who are also doing this. So it needs to be as simple and as easily understood as possible by people who may do it in the future, but also just by you in general. So that way you're able to easily understand what your results are saying. And then I don't think you have to, I think it's important that you don't have to be a quote unquote scientist to do any kind of data collection. So as Brian said, this past semester, me and some lab mates did a project with them where we launched a citizen science project with 3rd to 8th grade students, where first we went into classrooms and we informed students about ants while using that as a way to teach them about the scientific process. So what we did is, after the little lesson that we gave them, we then introduced them to a protocol to collect ants. So we went outside and we actually showed them what we wanted them to do for us. And then we gave them the materials that they needed to go home and collect ants for us, following this simple protocol that we did with them at school. And what we were hoping to accomplish with this is just to show them, one, how scientists are actually thinking about questions and how they're actually going about answering them. And then 2, we wanted to show them that everyone can be a part of science. Like, you don't have to be, like the old man in a lab coat. Everyone is a scientist if you're doing science. And then going back to this, I think I like to highlight the idea that the scientific process isn't necessarily this like step-by-step linear equation that we use to ask and answer questions. Rather, it's typically much more cyclical and crazier than that. So during this process of asking and answering questions, you're going to have new observations. New questions are going to rise. You're going to come up with new hypotheses as to why something might happen. So I think it's just important that science is always all around us. There's so many questions that are constantly waiting to be asked, and so many observations that have yet to be had with questions hiding behind them, which is what I love so much about science. And it's super duper exciting to me that there's so many things that we don't know and so many things that have yet to be answered. So I just want to thank you all for giving me the time and opportunity to be here this morning and letting me talk to you a little bit about what I did. If you want to keep in touch with me, you can follow me on Twitter at Hornfeldt Jacob. And on there, I typically just tweet about like bugs and other fun things that I find outside. If you want to keep up with the lab, you can follow us or see what we're doing at andrealucky.com. And you can email me for anything that you want at jacob.hornfeldt@ufl.edu.